speak to. We were talking last night, and I think this is the first time I've been in Sydney since 2017, just before I moved to America. So yeah, it's been a while. I think I was in this room actually viewing a bunch of you. Now, what I'm going to talk about today is the best practices in debunking misinformation and some of the psychology behind it, some of the research that has led to these best practices. And then along the way, I'm going to also give some case studies and a couple of war stories about putting those best practices into use. And I'm going to start, let's see, working a minute ago, but now it's disconnected. Turned off. The red dot works. I can always use the keyboard, right? No. Probably because of the recorded message. There we go. Okay, we're good. All right, so I'm going to be drawing on the debunking handbook. So we published this in 2020, and this was a collection of about 24 misinformation researchers from around the world, collecting all the psychology research into debunking misinformation and compiling it into a set of recommendations, communication recommendations. Here is what the research tells you are the best, most effective ways to counter misinformation. And if you had to remember anything from the debunking handbook, which is not a big book, but if you only need to remember one thing, it would be the structure of an effective debunking. There are a couple of key elements to debunking misinformation. The most important being lead with the facts, communicate the facts, identify what is the key facts that you want to dislodge the misinformation with. And I'll get into what I mean about that in a moment. You do need to mention the misinformation when you debunk it. Over the last decade, there has been talk about, can you debunk misinformation without even mentioning it? Because isn't there a risk that by mentioning it, you might elevate it or reinforce it or cause a backfire? Over the last decade of research, misinformation researchers have struggled to replicate backfire effects. And we've come to realize, and this is one of the reasons why we did the debunking handbook, we've come to realize that backfire effects are not the boogeyman that we once thought they were. And the much greater danger is leaving misinformation unchallenged. And thirdly, you want to explain how the misinformation misleads. What are the rhetorical techniques? What are the logical fallacies? Basically, when you present a fact and then a myth that contradicts the fact, explaining the fallacy helps people reconcile that conflict between fact and myth. I'll come back to that later. And then finish by reinforcing the fact again. You want to put the greatest emphasis on the facts, and you want people to come away with remembering those facts. It's been called the fact sandwich or the truth sandwich or the truth hamburger, like use all these metaphors. All of them kind of break down because if the truth hamburger, the truth would be in the middle, right? I've never understood that analogy, but anyway, that's so firstly, I want to look at this first point about communicating the facts and communicating or putting the emphasis on facts when you debunk misinformation. And the basic principle there is that when you're debunking misinformation, really what you're doing is you're taking misconceptions that people hold in their set of beliefs and you're removing those misconceptions. And that leaves a gap in people's minds. And people don't like gaps in their mental models of how the world works. And if you don't fill that gap with a replacement fact, then the misinformation comes back and continues to influence people. So I've just kind of got ahead of myself here, but imagine the way people understand the world is we build these mental models where everything is interconnected. There are causal links between everything. A causes B, B causes C. But what happens if a debunking tells people that B is false? What that does then is it removes that part of their mental model and they're left with a gap in their mental model. People actually prefer a mental model that's complete, even if it's inaccurate, over a incomplete model that is more accurate. And that's why if you tell people that something is false, but you don't replace that gap, then the misinformation comes back and it continues to influence people. And psychology researchers call this the continued influence effect. Not the most imaginative title, but at least you know what they're talking about. And so in order to debunk misinformation, it's not enough to explain that it's wrong. You need to replace it with a fact. It needs to be a fact that slots into that gap in their mental model. If you're saying to people, no, that, well, let me give you an example. Let's say you're debunking the myth that the sun causes global warming, and you tell them, well, that's impossible because solar activity has been going down at the same time that global temperatures have been going up. So the sun can't be causing global warming. You're explaining how the sun can't be the cause, but you're not replacing it with a alternative cause. So you need to also explain that here's how we know that carbon dioxide emissions are the main cause of global warming. So you're replacing that false cause with the true cause. So let me give you an example of, let me just jump back because you have to identify that fact that dislodges the myth, but you also need to communicate that fact in as sticky and compelling fashion as possible. So it's as if it's not hard enough to identify what is that key fact that dislodges the myth. You also need to make your communication of the fact even more compelling than the myth that you're debunking. And that's hard, particularly because misinformation is often simple, oversimplified even. It often grabs people's attention, it evokes emotional responses, it can be shocking because it's not bound by reality and facts. Whereas facts and reality are often nuanced and complicated and difficult to explain. And so that's a communication challenge, but there are tools that we can use to make our communication of facts stickier, more memorable, more attention grabbing. And so let me jump ahead again to an example. Now, one myth that has been around since, well, the early 2000s is the myth that global warming stopped in 1998, because 1998 was an unusually warm year because of El Nino, strong El Nino that year. And so the next couple of years after 98 were cooler than 98, and then that led to this myth that global warming has stopped. It turns out that around 2016, that myth dropped off a cliff. It just disappeared because we had 2014 was the hottest year on record, followed by 2015, followed by 2016. So we had 3 hottest years on record, and that myth just became untenable. But lately, we developed a machine learning model that detects misinformation arguments, and I'll talk about that later. And it detected that argument was coming back again. But this time they were saying global warming stopped in 2016. So they basically just the same argument and shifted it forward 2 decades. But this was in 2017. This was the day after the US pulled out of the climate accords from the Paris Agreement. And Scott Pruitt, who was the head of the EPA, I think, was giving a press conference justifying the US withdrawing. And one of his arguments for it was that global temperatures have been in a hiatus since the late 1990s. So even though I just said that overall the hiatus myth had died after 2016, it was still an attractive argument to Scott Pruitt. Now, normally when scientists debunk this type of argument, usually we make very scientifically appropriate arguments about how it's not a statistically significant trend, or you can't make inferences about short periods when you're looking at long-term trends. And this is all true, and it's a scientifically accurate way to treat the hiatus issue, but it's not the stickiest way to debunk the hiatus myth. And so a couple of years ago, we were just playing around with different ways that you could use a sticky fact to try to dislodge that myth. And we being the skeptical science team, were reflecting on the fact that global warming is about heat imbalance. The planet is building up heat due to greenhouse gases trapping infrared heat. And the heat intake is around, or at least back then, it was around 250 trillion joules per second. Now it'll be about 5,400. There'll probably be climate scientists in this building that will be able to give a more accurate number. But what we worked out was that amount was roughly equivalent to 4 atomic bombs worth of heat accumulating in our climate system every second. And just every second, day and night, all year, constantly. That's how much heat is building up in our climate system. About 90% of it going into the oceans. And I was actually at that time, I was living in Brisbane, but I'd come down to Sydney for an environmental conference with mostly environmentalists and activists. But they wanted a nerd to do the nerd talk at the start of the day, kind of explain why we're doing all this climate activism. So they asked me to come up and do all the graphs and get all the boring stuff out of the way. And then the activists came and talked about locking the gates and chaining themselves to trees and stuff. And all the cheers happened later on. There was no cheers during my talk. It was just the boring graph talk. And this was one of the graphs that I showed, trying to explain the reality of global warming. And unbeknownst to me, there was a News Corp journalist in the room covering the event. And this was the headline in the Australian, I think, in the Australian the next day, which was, so out of all the different talks, you picked this one slide in this one talk, which wasn't like I was breaking news or a new study. I'd just done some arithmetic on what we already knew, but put the emphasis on this heat imbalance and how dramatic it is. And then that got picked up by other papers all around the world because it was a sticky statistic. We were just trying to, I was just trying to debunk the myth that global warming had stopped by saying, actually, this is how much global warming is happening. And by trying to communicate it in a sticky way, it went viral. And what I took from that was that as communicators, and we're always trying to find ways to amplify our work, try to reach as many eyeballs as possible, and looking at social media and tweeting and doing TikTok videos or whatever. But if you can communicate your science in a sticky way, if you invest that time into thinking about how can you make your science stickier, that can go a long way and probably go further and deeper than you might get just trying to game social media. The other thing that I learned is that with great impact comes great pushback. And we found that some people didn't like the analogy, and there's an argument to be made that it's an analogy that has a lot of baggage. And so I was at a conference at AGU in San Francisco where I talked about this, and I talked about that analogy, and I proposed another analogy that would be less offensive and in fact should offend nobody. So I crunched the numbers. It was really half-assed arithmetic, but I kind of Googled how much, actually it's how much calories a person burns when they sneeze, and then I did the mass of a kitten. Someone said no, but kittens have a different metabolic rate. Anyway, it's a big number. That was the point. And I thought, well, no one should be offended by this analogy, right? I was wrong, and one person published a blog post criticizing the analogy, basically arguing that what I was really advocating was instant vaporization of every kitten in the world, and why did you hate little Oliver? So there's really no pleasing anyone. Don't take too much from that case study, other than science. I want to give another example of trying to take complex science and boil it down to something simple and sticky. So in 2013, we published a paper where we quantified the level of agreement on human-caused global warming in peer-reviewed papers about climate change. And we actually struggled with the paper in terms of Like we had lots of results. Like we took 12,000 abstracts, content analyzed them, identified that there were 4,000 papers stating a position on human-caused global warming. And then we categorized them and worked out how many of the papers endorsed human-caused global warming versus rejected human-caused global warming. And in the end, what we decided was the best way to communicate our results was communicate the fact that amongst those 4,000 papers that stated the position on human-caused global warming, 97% of them endorsed that humans were causing global warming. So this is how we communicated our results after the paper came out. So we put a bit of thought into, out of this paper, what is the sticky fact that, that best summarizes our results? And an important principle when you're trying to make your science sticky is you want to make it simple, but you don't want to oversimplify. And the way you do that is you think about what is the core idea in my science that I want to communicate. If you boiled it down to a single core idea, what is it? And in our case, it was that we were getting at, what we were trying to learn in this research was, is there an ongoing debate in the scientific literature about human-caused global warming? And we found that amongst the papers that were even talking about human-caused global warming, almost all of them endorsed that it was happening. And so that's what we wanted to communicate, that almost all the papers that stated the position endorse human-caused global warming. Because we communicated our research in this, with this simple statistic, a single number that people could repeat, the day after that, President Obama tweeted about our study, and then a few weeks after that, he gave a speech where he was unrolling out new climate policy, and he mentioned the study there. And so that led to a lot of attention to our research. In fact, I remember the day after the paper came out, I got a call from Peter Hannam, at the time he was a Sydney Morning Herald journalist, and he was asking, how did you feel when you saw about the Obama tweet? And I was thinking, who cares how someone feels? Like, shouldn't we be talking about the research? But and nowadays I often see journalists ask people that all the time, how did you feel when this? How did you see it? Once you see it all the time. It must be just in rule number 1 in the journalism handbook or something. And that principle I talked about before, with great impact comes great pushback. We found that in a big way once our 97% paper started getting a lot of attention, particularly from Republican politicians and conservative media in the US. So this was an interview where Senator Ted Cruz from Texas was arguing that the 97% consensus was based on one discredited study, which was confusing because ours was the 3rd study that found. So I've talked to William Anderegg and Peter Doran, and we debated which one of our studies is the discredited study. We weren't the first or the second to find that level, or the last as well. There's been many studies, and this was actually 3 years after that paper came out. We did a synthesis of all the consensus studies. It was actually a chance for me to work with a lot of my heroes. That was kind of my geek out Avengers moment, where I got to bring together all the consensus researchers, including Naomi Oreskes, who's a fan. But what the public were seeing were people communicating the 97% consensus, and then other people pushing back against it. They were seeing fact and myth. They were seeing these two counter arguments, and that's problematic when people see that. Now, there was a study published in 2017 by Sander van der Linden and his colleagues, where they tested what happens when people are exposed to conflicting messages. And he happened to be using consensus as the messages. The one message was 97% consensus, and the other message was misinformation, casting doubt on the consensus. What he found was that when people were told about the 97% consensus, it had a strong positive effect on increasing their perceived consensus as well as other attitudes about climate change. But when people were shown just the misinformation, it had a negative effect. It reduced people's perceived consensus and climate attitudes, both beliefs about the reality of global warming and support for climate action. So misinformation does work. It does have a negative effect. But the really interesting result is when people were shown both. They were shown the 97% consensus and the misinformation casting doubt on the consensus. And the two cancelled each other out. There was just no statistical change in people's beliefs. Misinformation can cancel out facts. When people can't resolve the conflict between fact and myth, then they end up just disengaging and not believing either. And this is the big danger for any of us in the business of communicating facts to people or educating people. Our facts, no matter how well we communicate them, can be cancelled out by misinformation. And so we need to be factoring that into our communication strategies. And so that brings us back to the fact and myth fallacy structure, because fact and myth, that's what van der Linden was testing. What happens when people are shown fact and myth? And when people can't resolve the conflict between the two, that's when they disengage. So what we need to do is help people resolve the conflict. And the way we can do that is by explaining the fallacy that the misinformation uses to distort the facts. When they understand that, then they can understand how these two conflicting pieces of information can coexist at the same time. And what van der Linden also tested in his study was with a fourth group in his experiment. He showed them a warning before showing them the misinformation. And what this warning did was it explained how the misinformation misled. And the misinformation was the Global Warming Petition Project, which was a website that listed 31,000 signatories of a statement saying that humans aren't causing climate change. No, humans aren't disrupting climate change. And this petition, well, firstly, let me go back one. Because it was a web petition, there was a lot of fake names on there. It was like Star Wars characters and Spice Girls and stuff. Just there was no quality control because it was an online petition. Secondly, because 31,000 sounds like a big number, it conveys the impression that there's an ongoing debate amongst the climate expert community. But in fact, because it was a petition of science graduates, there are actually millions of science graduates, and 31,000 is a tiny percentage of that. And thirdly, again, because it was just science graduates, it was graduates across a whole range of science fields, computer science, veterinary science, engineering, but less than 1% of the signatories were climate scientists. Is there a question?
Yeah, I'm assuming, given they weren't even checking on the science, that on the signatures, they didn't even check that the people themselves were scientists. Presumably you could put yourself down as sexy spice.
Yeah, Dr. Sexy Spice, a PhD in molecular biology or something. I mean, presumably, yeah. I think at that time, yeah, when it first came out, it was like that. I think after those criticisms, the publishers of the petition project went back and did remove all the egregious names. But yeah, I don't know whether they've checked all the 31,000 to make sure that they were, and I would be surprised if they did. But the point is there are multiple ways that this petition is misleading. And when you explain some of these misleading techniques, then what they did was they explained the misleading techniques, then they showed them the 97% consensus and the Global Warming Petition Project. And they found that when you did that, when you warned them before and you basically inoculated them against the misleading techniques, then the facts were able to have a positive effect again. So, in other words, explaining the techniques of misinformation neutralizes the influence of the misinformation to some degree. So now I want to, just to change our pace, I want to give an example of this strategy of explaining the techniques of misinformation using a case study. Now, so my research has looked a lot and run a lot of experiments where we tested explaining the techniques of misinformation and found that it neutralizes the influence of the misinformation. But ultimately, you want to find ways to deploy these kind of interventions at scale and try to actually shift the needle amongst the public. So one way that we've explored doing that is through digital games, which then you can reach a lot of people. You can engage them using all the tools of gamification, and hopefully have an influence on inoculating the public, building public resilience against misinformation techniques. And so what we developed was originally the Cranky Uncle game, which was focused on climate misinformation. Then we were approached by UNICEF and the Sabin Vaccine Institute, interested in doing a vaccine version of the game. And because the game was focused on explaining the techniques of misinformation, it had a very critical thinking emphasis. That approach lended itself to just shifting across to another topic, because those same misinformation techniques are used across all science topics. And so we developed the Cranky Uncle vaccine game. And the way it works is you have a health worker explaining the facts of vaccines, and then you have Cranky Uncle explaining how he uses different misleading techniques to cast doubt on vaccine facts. So it's a game cartoon version of fact myth fallacy, where we're combining the fact-based approach and also the fallacy or technique or logic-based approach. And what we do is we just go through like 10 of the main fallacies used in vaccine misinformation. The other thing we do is take advantage of gamification by showing them examples of misinformation and having them identify what is the technique or trick that's used in each example. And what we're doing here is getting them to practice critical thinking. We use all the tools of gamification, collecting points, leveling up. The further you get into the game, the more cranky points you collect, and Cranky Uncle gets crankier and crankier, and his face gets redder and steam starts coming out of his ears. So it's using all the elements of games that keep people, incentivizing them to keep playing and playing and getting further and further. But really what we're doing is the further they get and the more they practice, the better, the more accurate and the quicker they get at spotting misinformation techniques. Because UNICEF were interested in improving vaccination rates in specific parts of the world, and it was also important to all of us that the game was relevant, culturally relevant in each country that we deployed the game in. We held co-design workshops in each country. So this was, we started in Uganda and Kenya, where we showed them sketches of the characters in the game, showed them the content. They gave us feedback on what made sense to them, what needed to change, what they wanted to see in the characters so that they were seeing themselves in the game. And we ended up with it. Now that I look at it, it kind of looks like a sitcom kind of cast of characters. But this was the final characters. Things we learned was accessories are really important, particularly for young people. Apparently, young guys wear buds in just one ear. Did people do? Is that right? That's what they told us. Old dudes have watches, wear old watches, and put pens in their pockets. Apparently, we started with we did a sketch of the older woman having a certain headwear, and we're told that's how West Africans wear it. We don't do it that way. And so they sent us pictures to make sure that we got all these details exactly right. And then we ran a pilot test in Uganda and Kenya where we had 1,000 people in each country play the game. And before they started the game, we had them fill out a survey inside the game where we asked them to look at various statements and assess how true or false they thought they were. And there were 2 factual statements and 6 fallacy statements. And what we found was overall, there was fairly good, fairly good at identifying facts and fairly good at identifying fallacies as false. But we did show a significant increase in in identifying facts and also a significant decrease in belief in fallacies from before the game to after the game. And this was an important pattern that we were hoping to see. In fact, I've run a lot of experiments as a psych researcher where, you know, you always want to see results in your experiments, but often you don't get significant results and you think, oh, well, I mean, I had a crack. But this was so much that went into designing this. I was actually really nervous just before the data came in, because I was worried, I hope that we see results, otherwise people will probably be a bit cranky at me. But in misinformation research, there's a concept called discernment, which is becoming more and more prominent, which is not just reducing people's belief in misinformation, but you want to avoid reducing their belief in facts as well. In other words, you don't want to just make people cynical about everything. Because if you just tell people, look out, there's fake news out there, don't trust anything, then they're not going to trust accurate information. They're going to trust facts coming from educators and scientists. That's not what we want. We want to see belief in factual, accurate information go up and belief in fallacious argument come down. And we did see that. And I think because the game is that combination of fact-based and technique-based, not only explaining the techniques in misinformation, but also explaining vaccine facts as well. At the beginning of the game too, we also mentioned a few vaccine attitudes. We asked some questions about their general attitude towards vaccines and also their intent to get themselves or their children vaccinated. And again, we did see a significant increase. And particularly important was seeing an increase in the intention to get vaccinated, which is actually a difficult behavioural intent to shift in vaccine interventions. And this overall was quite high because I think that 80% of the people were already likely or very likely to get vaccinated. But amongst the 20% of our participants who were unlikely or very unlikely to get vaccinated, we saw that 58% of them shifted into the likely options. So we did see a big shift amongst that vaccine hesitance towards being more vaccine accepting. And these are the countries where we've been running co-designs and or pilot testing. And the one that we're about to start a pilot study in is in Pakistan. So we've already done the co-design workshop. Here are the Pakistan characters. And does anyone know John Kocher? He's a climate communication researcher in George Mason. And this guy looks just like John Kocher. I don't know, it freaked me out when the designer first. Anyway, I digress. All right, I want to talk about one more case study because my work's really been looking at two things. One is technique-based inoculation, things like the Cranky Uncle game. And the other work has been on what we call in the misinformation field, the holy grail of fact-checking, which is automatic detection and debunking of misinformation in real time. And it's called the holy grail because it is really difficult. You're trying to detect misinformation as it's coming online. You don't know what are the new arguments going to be. That's one of the challenges. You don't know what form the arguments might take. With climate misinformation, though, you kind of do, because they've been using the same arguments since the early 1990s. It's the one thing where climate deniers are probably the best recyclers in the world. They keep using the same arguments. That's why the hiatus in 1998, they're still recycling it. They just changed the dates. And so that gave us the opportunity to potentially detect climate misinformation. And so in 21, I worked with some computer scientists from the UK, and we trained a machine learning model to detect and categorize climate misinformation. First thing we had to do was build a taxonomy of misinformation arguments. And this is a simplified version of just the top 2 levels. It's now going down to 4 levels, but The main thing here is that there are 5 main categories of climate misinformation. The first 3 are the science arguments, or science in air quotes arguments, arguing that global warming is not happening, it's not caused by us, or it's not bad. The 4th category focus on solutions. Generally, solutions don't work or they're harmful. And the 5th category is attacking climate science. It either attacks the scientists or it attacks the science itself. Can't trust climate models, can't trust temperature data, can't trust paleo data. Just all of these category 5 arguments are about eroding public trust in climate science. So we trained our model to detect these different arguments. And then we took 20 years of climate misinformation and put it into our model in order to build a history of climate misinformation. And this is what we found, looking at conservative think tanks, which have been one of the longest lasting and most prolific forms of misinformation. And 2 real big patterns jumped out at us. Firstly, a gradual trend towards solutions misinformation. Climate misinformation is transitioning away from science misinformation towards solutions misinformation, presumably because the science of climate change is becoming more and more undeniable as the science gets stronger, and we're seeing it happen in front of our eyes. Secondly, that 5th category, attacking climate science, is much more prevalent than we realize. And in fact, those first 3 categories have a minimal presence relative to the other 2. And so that means that while people like myself have spent most of our time debunking these 3 categories, all the action is actually about attacking scientists and attacking the science itself, while there's a dearth of research into understanding what impact that has and how do we counter it? How do we rebuild trust, particularly given all these efforts to erode trust in climate science? And just recently, I've been working with computer scientists at Monash University on continuing to develop this model. We've recently updated the model, adding more training data from Twitter to make the model better at detecting and categorizing climate misinformation in tweets or X's or whatever it's called. We put 6 months, I think it was like 3 or 5 million tweets, climate tweets, into our model. This was it was over the period of the second half of 22, mainly because it was the period when Elon Musk took over Twitter, and we were wondering whether there was a Musk signal. And spoiler alert, we didn't see one. I was surprised. We thought there might be a spike because he was letting all these far-right accounts back on the platform. But at a global level, that wasn't enough of a signal to make a difference. But what we did find was an even greater prevalence on Twitter on attacking scientists. So 5.2 was attacking people, not attacking climate science like models or temperature data, but attacking the scientists themselves. That was about 40% of climate misinformation on Twitter, while 20% of it, the blue area, was conspiracy theories. So around 60% of climate misinformation on Twitter is either personal attacks or conspiracy theories. So what we took from that is that climate misinformation has different emphases depending on the platform or the source. Conservative think tanks are focused on solutions. Blogs were focused on attacking climate science, while Twitter is focused on attacking people, climate scientists. And so we were doing all this research because ultimately we're working towards the Holy Grail, not only detecting misinformation, but debunking it. But to debunk it, you need to follow this structure, right? You need to explain the facts, the key facts, and also explain the fallacy. And so the closer we got to, all right, we solved the detection problem, then we realized, oh, well, we have to also do all these, tick all these boxes. We realized there was still a lot more work to be done. And so over the last year, we've been working on detecting fallacies in misinformation. And we are just in the process now of preparing this paper for submission, but you can actually read a draft of the paper at that URL at the top, where we have trained a model to detect fallacies in climate misinformation. And so, apologies if this is a bit gobbledygooky, but I really like this table. But this is a confusion matrix, just showing how good our model is at detecting different fallacies. And what we find, well, firstly, let me just say, there's only been a few studies into automatic fallacy detection in the past. Generally, they're about 50% accurate. So we've managed to take a step forward from there, getting about 70 to 90% accuracy. But not all fallacies are equal. Some are easier to spot than others. And generally, we found that the fallacies, we call them structural fallacies. The fallacies where you can look at the text and glean what the fallacy is based on just the way the text is, the patterns in the text. For example, a false dichotomy or a false choice is usually presented as an either-or argument. Ad hominems are usually presented, like you can tell an ad hominem because there's usually nasty adjectives in the text, the semantics are quite easily spotted. But a lot of fallacies require background knowledge. Misrepresentation or oversimplification or slothful induction requires you to have some climate knowledge in order to know that this statement is oversimplifying the science, or it's slothfully ignoring relevant evidence before coming to a conclusion, that kind of thing. So we're still in that process of training our model, but ultimately what we are in the process of doing right now, this year, and also if you want to play around to see what this tool can do, go to that URL at the top of the screen. I should be putting QR codes on my slide. Sorry, it's a habit I have not got into yet, but you can enter text into this tool and it will give you probabilities of each fallacy, so that if it thinks there's a high probability of a specific fallacy in that text, it will tell you. So it's a good way to kind of stress test the tool, see how good it is. Just as the tool came out, there was an article published, an interview with Tony Abbott, and I just copy and pasted a few of his arguments and threw them into the tool, and it picked all his fallacies quite accurately. So I was quite pleased. This is what we're currently doing, and whether this works or not, we are yet to determine. But the goal here is to use generative AI to debunk misinformation. Just imagine you give ChatGPT some misinformation text and ask it to produce a debunking, according to the fact, myth, fallacy strategy. And we actually started with that methodology and found that ChatGPT is awful at spotting fallacies. That's what led us to having to develop our own model to do it. So now our strategy is to firstly use our cards model. That was the large machine learning model with the 5 categories. Use that to detect if there is misinformation in some text. If there is, we use the other model to find the fallacy. We identify what claim in our taxonomy is in the text. And we've already manually deconstructed all these arguments, and we have that database ready. And then we pull that information together, put it into a prompt. So we're kind of hand feeding ChatGPT or whatever generative AI model we're going to use. We hand feed as much of it, kind of get as far along the way as possible with factual information and the right critical thinking content, and then ask it to produce in natural language a fact, myth, fallacy debunking. And then just to make things extra difficult, we're also seeing whether generative AI can help grade the quality of the debunking. We have not yet determined whether it's generative AI is good at grading generative AI. Our first test where it was like, yeah, this is fantastic, but we thought it was a bit self-serving. So that's ongoing. And where we're eventually hoping to end up with this technology could be applied in a lot of different ways, but this was the original concept we had when we started doing the research, which was imagine an app where we detect misinformation on all the different social media platforms, and then people can scroll through a feed of misinformation posts where it says, this is the fallacy or this is the myth that this text contains. And then they can choose which ones they want to debunk. And then it pre-fills a social media post with a debunking that they can manually curate, edit, personalize, whatever, and then they can post it, empowering people to quickly respond to misinformation. If enough people are using it, we're getting corrections out to misinformation from humans, not from bots, but just empowering them, giving them facts and critical thinking explanations on a silver platter, making it easy for them to post. That's one possible application. We haven't even got to this part because we still have to solve a lot of problems for it. But there are multiple ways that you could apply this kind of research. Look forward to when we get to that stage. That's all I was going to talk about, but happy to answer any questions in the time we have left.
Very much, John. I'm sure there's questions, so please fire away.
Thank you for your presentation. For the attacks on the solutions, was there any filter in that for people possibly attacking really, how do I say this diplomatically, out of the box geoengineering solutions like reflectors in space or dumping ice in the Gulf of Mexico? What do you think that contribution would have been, like, negligible?
I think it was negligible. I don't recall geoengineering even coming up in our taxonomy. And in fact, we even had nuclear as one of the things in version 1 of our taxonomy. And it's actually fallen out of version 2 because it was just coming up so little, as in pro-nuclear arguments, which we were seeing occasionally on conservative think tanks. But it's very much a moving space. This was the first version of our taxonomy back in 2021. Just this year, we've updated it and we've incorporated all of the William Lamb's discourses of delay. This was a paper published a year or two ago, which was all policy arguments, and we only had a couple of them in our taxonomy. So we've restructured the taxonomy to bring them in. I think technological optimism might have been one of the discourses of delay, so it would be captured by that, I think, in the new taxonomy.
Lots of questions. Kristen and Saoirse, then Crystal.
Thanks very much for this talk. That's really exciting research. I was wondering about, or one thing that worried me most, I suppose, is that increase in misinformation that targets climate scientists and the climate science, obviously. And so I was wondering whether you had any data as to how effective your fact, myth, fallacy approach is, depending on the different types of misinformation. Because obviously when you're just talking about people, it gets into a he said, she said kind of situation where it's really difficult to debunk.
Yeah, no, I don't. That's one thing that we're just looking at now. And there are a couple of ways to approach it. Like a lot of my work's based on inoculation theory. And so one thing we're exploring is, can you inoculate people against ad hominem attacks against scientists? But we're only in the early stages of designing that research. The other approach is not so much a communicate. Well, it's more a behavior change approach that we're looking at, which is when people see ad hominem attacks and hate speech online, it's encouraging people to push back against it, because that can have an effect on mitigating or just discouraging people from continuing that kind of uncivil behavior. So there are different approaches, and we're really just in the early stages of looking at it. But I don't have an answer, because I think you're right. There really are three different types of misinformation: solutions, science, and attacks. And my instinct is that they will require different strategies. Saoirse?
Thanks so much for the talk. It's really, really impressive stuff. So I guess in a you touched on this a little bit in the last part of the talk, but I was wondering if there are certain groups of people for whom some of these strategies might be more or less effective, if you found any of that throughout your work.
Yeah, so one of the first studies I did during my PhD was and it's really what started me down this critical thinking approach, was finding that when you just explain the techniques of misinformation, that works across the political spectrum, say. Climate misinformation has a disproportionate influence on people at the conservative end of the spectrum. But when you explain the techniques of misinformation, it neutralizes misinformation equally across. So it basically depolarizes misinformation, which is otherwise polarizing. So the technique-based approach, A, can depolarize across the political spectrum, and B, you can sidestep a lot of those kind of cultural triggers by explaining the techniques in a less polarizing context. In my experiment, I was explaining how the fake expert strategy used in the global warming petition project was initially kind of it was kind of pioneered by the tobacco industry in the mid-20th century. They had things like the White Coat Project, where they were trying to use fake experts to mislead the public about the health impacts of smoking. And by teaching people the fake expert strategy in that context, then showing them the global warming petition project, an example of the fake expert strategy, then that didn't work anymore, didn't persuade people whether they were conservative or liberal. So that's an argument for the technique-based approach, but I'm still drawn to this combination of fact-based and technique-based, because you want to see that discernment, you want to see belief in facts go up and belief in myths go down. So yeah, I don't know, that's a bit of a word salad answer. Crystal.
I just have a question on the misinformation part that I thought was key, was that a lot of times it evokes this emotional response. And so I work in a field that it's very money, numbers based, it's very little emotive, so it's often hard to try to package facts that are going to have some sort of emotional response as well, right? So I'm wondering if, a lot of thought has gone into the ways to kind of make your facts sticky, but there's an element of, is that piece 100% necessary, or do you do the best you can on that front, or?
Emotion's not the only way to be sticky. And I don't have it in my presentation, but often I refer to this acronym, the SUCCESS acronym, for how to make your science communication stickier. And it's 6 boxes you can tick. You don't have to tick all of them, but the more you tick, the stickier your science gets. And SUCCESS stands for simple, unexpected, concrete, credible, emotional story. And you don't have to do all 6, but if you can tell a simple story in the form of a story, that will be better than just giving them a statistical argument. Or you can give them an unexpected statistic, like 97% scientists agree. When I first started telling that to people, they were like, oh, I thought it was 50-50. So it was a surprising statistic. Or 4 atomic bombs per second worth of heat every second. It was a surprising statistic. It was simple, it was concrete, so it ticked a lot of boxes. So you can, there's multiple ways to make your science more compelling. The other thing I'll say is that in terms of trying to counter misinformation, and I draw on inoculation theory, and there are 2 elements to an inoculating message. The first element is the warning of the threat of being misled. And then the second element is the counter arguments explaining how the misinformation is wrong. And most of the heavy lifting in inoculation is actually the threat warning. And that also has an emotive element to it, because it appeals to people's desire not to be misled. Nobody likes being misled. So it's almost a combination of system 1, system 2 thinking. It's like system 1 warning that danger will Robinson is warning, there's people out there who want to mislead you. and here are the ways that they want to mislead you. But that kind of, not an emotional warning, but it does just raise people's cognitive threat of being misled. So that has somewhat of an emotive element to it as well.
One quick one from Amy, and then we better finish.
Thanks, it was interesting talk. I have a question about the difference between pre-bunking and debunking. I know that there's a distinction in the field or in the literature about this, and I guess some of the intervention that you use are pre-bunking rather than debunking. First, is it a valid distinction now? Still it's valid? And also, why such a ordering, simple ordering has a huge impact?
Yeah, ordering does matter, and pre-bunking, like doing a correction before people are showing the misinformation, is different to debunking it after, because debunking after, you're trying to undo the damage, whereas pre-bunking, you're trying to stop the damage from happening in the first place. So there are different dynamics, and the way that people receive, the order in which people receive information matters as well. And we've actually done one study where we tested pre-bunking directly against debunking, 2 different conditions, but also we tested the fact-based approach, explaining the facts to debunk the misinformation, versus the technique-based approach, explaining the misleading fallacy. So we were doing either fact-based pre-bunking or technique-based pre-bunking or fact-based debunk, with 4 different conditions. What we found was the technique-based approach, explaining the fallacy, was equally effective either way. So explaining the fallacy is effective pre-bunking and also is good at debunking and undoing the damage afterwards. But with fact-based, we found that it only was effective in countering the misinformation if the fact-based correction came after the misinformation. So they saw the misinformation and then they saw the factual debunking, and that was just as effective as the 2 technique-based conditions. But if we explain the facts to people first, and then the misinformation was the last thing that people saw, the misinformation cancelled out the facts. It was a similar result to what I showed with the Van der Linden study, where misinformation can cancel out facts. It happens in certain contexts, and ordering matters and the technique matters. And so that again has drawn me, another reason why I'm attracted to this critical thinking approach. A, it's more robust regardless of the ordering. And B, it's a way to make your facts more robust. Like, we're sending our facts out into the world where we don't know what people have been exposed to in what order. But if you wrap some critical thinking bubble wrap around your facts, then you give it more of a fighting chance at being effective. Probably a good place to end it.
Absolutely. Thank you very much, Frank. For everyone to take away. So thanks again, John, for coming along. Thank you for coming to watch. We will be having more ICRR seminars throughout the year, so keep an eye out for adverts for those. And also, if you have suggestions for speakers for the seminar series, then please contact us. Thanks again, John, and thanks for coming.